Hi, everybody. Thanks for joining us today on the webinar. We're here to talk about automated anomaly detection with machine learning in the Elastic Stack. My name is Steve Kearns. I'm the Senior Director of Product Management here at Elastic, and I'm very pleased to be joined today by Steve Dodson, the tech lead of the machine learning team. Steve joined us about 7 or 8 months ago as part of joining forces with Prelert, which is a company making this the core engine of this machine learning technology that we're going to be talking about today. First, before we dive in, a little bit of housekeeping and logistics. The slides and the recording will be available following the webinar. We get a lot of questions about that. Don't worry, if you've registered, you'll be getting this. And if you can, we'd love for you to join us live for chat in IRC. If you've joined it via our website, you'll see a little link underneath the video saying join the chat. You can just enter a username there and join us right in your web browser. And one other note here. If you are viewing this and it's not crisp and clear, we're using YouTube to share the video, and in some cases YouTube selects a lower resolution. So use the little gear icon in the lower right-hand corner and select a higher resolution there. I think it's going to make a big difference for the experience. And with that, why don't we dive in? For those of you who are joining us for the first time and aren't familiar, Elastic is the company behind the Elastic Stack. This is an open source platform for data analytics. The core of the platform is Elasticsearch. This is where you would store, search, and analyze data. On top of Elasticsearch, in the visualization layer, we have Kibana. It allows you to sort of manage and monitor your stack, but more importantly, it allows you to visualize the data that's stored in Elasticsearch. And there's a lot of ways to get data into the stack, into Elasticsearch. It has great APIs. If you're writing applications, you can write directly to it. But if you're dealing with operational data, security related or simply IT ops, we've got a lot of good ways to get that in, starting with beats, lightweight edge shippers. So this runs on edge machines in your infrastructure, pushing data, oftentimes right to Logstash, which does the enrichment and stores that data in Elasticsearch. Now, on top of the Elastic Stack, we have XPack. This is a commercial extension to the open source products. It allows you to install one extension into Elasticsearch, one into Kibana, one into Logstash, and it brings a number of additional capabilities. So this is role-based access control for accessing the data stored in Elasticsearch. This provides encrypted communications. It also provides a number of other capabilities like alerting, monitoring, reporting, graph. And we have lots of good content on all of that. Today, we're really going to be focusing on this new component that we just added in 5.4, machine learning. Before we get into the details, one last note. If you haven't used Elastic Cloud, this is a great way to get started with the stack. It's a great way to run in production where you don't have to manage the whole stack yourself. So definitely do check that out. One important note, though, the machine learning features that we'll be talking about today are not available in Elastic Cloud today. One of the ways that we recommend running machine learning in production involves dedicated nodes of Elasticsearch for machine learning purposes, and today Elastic Cloud doesn't allow us to configure that. And so stay tuned, there's a lot to come on that, but today, as of 5.4, machine learning is not yet available in Elastic Cloud. And with that, let's just jump right in. Machine learning is a very big term, I'll say. Depending on who you talk to, they think a lot of different things, right? Machine learning technology is used for things like self-driving cars and the artificial intelligence for playing Go and StarCraft and a number of other things. In fact, when I think about machine learning initially, I come from a natural language processing background, so I think of entity extraction and name resolution, all kinds of fun things like that. But we want to be very specific about what does this thing actually do. And what we're doing, XPack Machine Learning, is doing anomaly detection for time series data. And we want to be very specific about what we do, but we also want to make it clear that we called it machine learning not for the buzzword, but because this is just the first of many features. We have big ambitions for where we're going with machine learning. I can't wait to talk to you about those, but first, let's dive in on anomaly detection for time series data. And why did we pick this as the first major area for investment? And the real reason is quite simple. In almost all cases, when you're dealing with time series data, especially operational data, security data, business, it almost doesn't matter. Anomalies mean trouble. So, let's say, for example, you're in an IT ops kind of use case. You're using maybe FileBeat with the new FileBeat modules to go grab Apache logs. And the new FileBeat modules, they actually come with this dashboard that we're looking at here. It's really powerful. But when I start to ask some questions about that, I zoom in a little bit and I say, well, let's look at the number of requests that are being made and the number of bytes that are being transferred to the top 5 countries that are accessing my web properties. And this is actually a beautiful chart. It tells us a lot of interesting information, but it doesn't necessarily let us answer some of the questions we might have. Am I seeing unusual traffic? Has my traffic dropped dramatically? And why? Did I lose a web server, or what happened? Or maybe I want to ask a different question. Are there bots or attackers that are visiting my website, either scraping it or trying to find a way in? And how do I detect that just by looking at this kind of dashboard? A lot of these things are very difficult to spot with your eye. And this is the same kind of thing that we see in other places as well across IT operations, whether it's looking at logs from your database or even just the messages that are coming across syslog from all of your different devices in your infrastructure. Very difficult to identify when something unusual is happening. And the security analytics side of things, there's a lot of different places and questions that you might want to ask, right? Especially given the recent attacks with the WannaCry, WannaCrypt, and so forth. One of the things you might have is you might be looking at DNS data. Maybe PacketBeat is collecting DNS data for you, and you can start to ask questions. Are there signs of domain name generation algorithms that could indicate data exfiltration or command and control behavior? Or even something even simpler, right? I may want to look at the traffic, network traffic in and out coming from all of the machines in my infrastructure using MetricBeat. And then I can start to answer questions. Are any of these machines acting different from the others? And could that indicate an insider threat? And finally, FileBeat has a great module now for authentication logs from Linux machines. And this lets you actually collect a lot of this information across a wide range of your infrastructure. And you can start to answer questions like, is there a brute force attack underway? Even if they're only peppering each server with 1 or 2 requests, that sum total might be something significant. So a lot of questions that you want to get answers to that don't necessarily line up with a single dashboard, for example, a simple dashboard. We also see a lot of really interesting use cases that don't really fall into IT operations or security analytics, and so we sort of group them all together. And this is really the kind of use case that I find very interesting. Imagine, for example, imagine you're a gaming company, for example, and you've got latency information about all of your users, right? This could be anything from a gaming company to something rather significant. But do we see an unusual spike in user latency? First, how do we tell what unusual is? And then once we find it, how do we know if it's a server problem in our data center, if it's a connectivity problem from our data center to our customers, or if it's a problem even further down at the ISP of an individual set of users, for example? We also see this for the Internet of Toasters or Internet of Sensors, right? There's so many industrial devices, everything from self-driving cars to pick your favorite sensor. There's all kinds of data that those are sending back above and beyond, in many cases, just the metric that they're capturing. So how do you detect when a rare event occurs? I could search for it if I knew what the event was going to be. But if I don't know what the rare event is going to be, because I'm not sure when it's going to occur, how do I find that? And then what does that mean? Does that indicate a failing device? And how do we figure that out? So one way that you approach this today, right? You create dashboards. Kibana makes beautiful visualizations. It gets better every release, and actually 5.4 is no different. There's a bunch of great new features in there. But in a lot of cases, if you're looking at just one metric, probably in a lot of cases you could spot an anomaly, right? Oh, that looks like an anomaly. You have trouble maybe answering questions like, does that happen every Tuesday? Or is this really an anomaly, right? How do I tell if it's a monthly thing or a weekly thing? But a human could probably figure that out relatively easily. But when you start to think about the number of different metrics in your infrastructure, let's imagine, right, a hypothetical that you have, you can create dashboards for every metric that's potentially going to matter in your infrastructure. Great, let's say you can do it. And let's say you can actually afford to pay enough people to sit there and watch all of those dashboards 24/7. I don't think there's enough coffee in the world to keep those people awake looking at dashboards trying to spot these anomalies. So it doesn't scale, right? Dashboards are great. They're a great way to drill in, a great way to look at the specific information, but they don't solve that whole problem on their own. The other thing that we see a lot is rules. And if you've been following Elastic for a while, you've seen I've actually done a number of webinars on our Watcher product, which allows you to create rules. And there are some problems that are great for rules. For example, if you're treating your infrastructure like pets rather than cattle, you might say, oh, well, my primary domain controller, if that goes down, I need to know. And I've got this heartbeat, and if that heartbeat doesn't beat, I need to know. And so we could do that very easily with a rule, right? There's no reason you couldn't. That's very simple. Other things like an SLA, if the response time exceeds the SLA that I have in my contracts with my customers, I need to know that because that's costing me actual money contractually. And those ones, again, are great for rules, but when you've got data like we've got on the screen here, it doesn't scale. How would you create a threshold for this? These kinds of things are very difficult. You could maybe section it by the time of day, and you could say from 4 to 6 p.m. I expect this, and from 6 to 8 I expect this. But that's very fragile. And you know, the next challenge you have is once you do that, imagining you could, now who updates that? What happens when the time changes and the 4 to 6 range is now the 5 to 7, and all of the things change a little bit, or your user behavior changes because you introduced a new feature, or your infrastructure changes because you're running Docker and you just changed out, I don't know, Amazon instance types. And that has a material impact in many cases on these different metrics, but rules aren't helping you solve that problem necessarily. And the other thing that we see a lot in talking to folks about the machine learning technology that we've got here is they say, you know, they're seeing a lot of false positive with rules that they create for those same reasons, right? The users change, the infrastructure changed. A lot of things happen in the dynamic sort of world of infrastructure today that cause rules to go out of date quickly and cause alert overload. And then there becomes so many alerts that your ops team and your analysts don't have the resources to go through it. And even worse, if you sort of relax the rules, now what are you missing? And you, at that point, you don't necessarily have the ability to even see what you're missing. So rules don't necessarily scale here. And this is really one of the things that we've been very focused on. I think you'll see this, you know, as I hand it off to Steve here in a moment. We're trying to make the simple things simple. There is nothing simple about the machine learning algorithms that we use here. We've been developing these for over 6 years, but we want to make it easy to experience. The goal of this product at sort of the beginning end is to say, if you can create a visualization in Kibana, you should be able to create a machine learned model, and you should be able to detect when anomaly occurs in your data. And that's exactly what we're trying to do. And so as Steve walks us through the demo, I think you'll see the power of the algorithms make it so much easier for us to make it easy to create and manage these machine learning jobs and anomalies and take action based on it. And with that, why don't I hand it over to Steve Dotson, who can take us through an actual live demo.
Great, thanks, Steve. That was great. And what I'd like to do now is really base the rest of the presentation on actually showing you the product and the type of things the product can do. So I'm going to start off with a very simple demo. In this case, I'm looking at a key metric. The use case here was actually a large retailer, and for them, one of the things they were really interested in is looking at their orders per minute. If this metric dropped significantly, then that often indicated there was an application issue or something going on with the back end. And as orders for them were revenue, this was something significant, and this is something they wanted to identify as early as possible and to alert on. But as Steve mentioned, setting up rules and thresholds on these type of this type of data is difficult. You need to know where to set it, and also if you have sort of intraday drops, you need to have some sort of threshold that accounts for periodicity. So I'm going to go into how we can model single metrics, and really sort of this is where we recommend you start using the app or evaluating the app, where you can start with metrics that metrics that you care about, and things that you want to alert off if they change. So you'll see that there's now a new icon here, the machine learning icon. And if I go into that page, this is going to allow me to create a job. And what a job is really a unit of work, and really a unit of analysis work. And in this case, I'm going to create a job which is based on a single metric, analyzing a single metric. I'm going to use a Kibana index pattern to seed this and to tell me what data to analyze. I can also analyze data from searches I've saved as well. In this case, I'm interested in counts. In this particular example, I'm running this all locally on my laptop. I've got 5.5 million transactions here, and here are the raw transactions. Really what I want to do is take this data, I want to automatically analyze it and to identify anomalies in it. And the real purpose of this ultimately is to do this in real time as the data is being indexed in Elasticsearch. I'm showing you this on historical data, but I'll show you how we can do this in real time as the data is going in, and how we can extend that to actually alert when there's changes in this data. I'm going to create a job. I'm going to give it a name. And when I press this button, this is sort of where all the engineering that we've been working on for a long time happens, where the machine learning plugin is going to go and query Elasticsearch, retrieve the data from Elasticsearch, push it through the machine learning nodes, which perform the analysis, and automatically model this data as it's being streamed through left to right through the analysis engine, and then calculate the probability of the current behavior based on what we've seen historically. But I'll explain that a bit more later. But for now, I'll just click on Create Job. So the blue shaded line here that's being filled in is some visual representation of the statistical models, the machine learned models that we're creating as the data is being streamed through us. And the sort of the swim lane, the DNA lines that are coming across there represent anomalies we've detected in there. So I'll dig into this in a bit more detail in this view, and I'll just widen that out a bit. And I'll start on the left-hand side. And this sort of gives you some idea about what we're doing internally. When I configured this job, I didn't state any configuration saying thresholds or any configuration saying whether the data was periodic or not. And you can see that effectively we're learning the behavior of the data. We're learning typically the bounds and the behavior of this time series as it's being streamed through the machine learning engine. So initially we don't know much, so we start off with quite a wide variance in the data, and then as we see more data we can make inferences such as this exhibits some sort of periodic pattern and our bounds become tighter. And then when something drops below those bounds or exceeds those bounds, we can say, okay, this is an anomaly. And scrolling down here, we can see, here's an anomaly we've identified, and we can see typically we expect a value around here. This is the actual value at that point, and we've calculated a probability of this occurring, which is very low, and we've normalized that into a score. So there's a lot going on there, but ultimately, what this shows is that we can take these time series data, we can automatically model them, and we can inform you when those time series data change. So, sort of in summary, here what we're doing is we're using unsupervised learning. So we're not creating a model that needs to be trained once, then continually retrained. We're learning online as the data is being streamed through us, and we're learning a model which represents, basically based on past behavior. We're then using this model to predict future behavior. So effectively, at a particular point, we're using historical behavior to understand what is the probability of this current behavior. And based on this, we can make this actionable. We can actually make a decision. We can create an alert. And really, that's sort of the ultimate goal is, as things are going into the system in real time, we can create these alerts. Okay, so that's very simple, and that was an example of us identifying anomalies in say orders per minute. But the next question is, well, I've got this say big application infrastructure that's supporting my order system, and why has this anomaly occurred? What's going on the back end? And in this system, this demo is obviously slightly simplified because it's all running on my laptop, but effectively behind sort of the back end of the order processing system consists of a set of services. And some of these services involve authentication, looking at inventories, looking at stock control, and so on. Sort of the next stage with the customer was to say, well, out of the back-end services, let's model not just a single metric there, but let's model the response times from all these services and look at what's anomalous. So going to the machine learning tab, I'll show you how you can create a job which moves on from just being a single series to multiple series. So in this case, I'm looking at these services, and I'm looking at the response time. And in this case, when I click on this, you'll see there's sort of this really cool graphic which shows we're now not just analyzing one series, but we're analyzing multiple series concurrently. And this is sort of where some of the power of automating this process comes in, where instead of where you can actually start looking at large numbers of metrics and getting the automated anomaly detection to do the work for you behind the scenes to understand whether there's been changes in things which are, as Steve said, more things than you can more things than you can visually represent on operations dashboards. So, creating a job in this case. The visuals are slightly different here, but we're doing a similar thing. But in this case, we're actually looking at each of these services. We're baselining each of these services in a similar way that we did on the first example here. And the top view there represents some type of visual indication of anomalies and things that we've identified in the system. Okay. So when that ends, I'm going to go into the results page. And this is what we call the Anomaly Explorer results page, which is really sort of the general results page for jobs which aren't just single metrics. And what we have here is a swim lane which represents overall the anomalousness of the system. So I've given this job a bunch of metrics representing the different services, and I can see that at a particular point there's an anomaly here. I've also got a breakdown of anomalies, the top 10 anomalies in services below there, and we can instantly see that this inventory service in US East is anomalous at this time, and when I drill into this, I get a sort of a preview of that anomaly, and again sort of a visual representation of what's going on, what the probability was, and a normalized score for that. Okay, so that's great. So I've looked at the KPI, I've looked at some metrics, and I can continue this to look at more metrics as well. But one common question is, well, how about if the backend infrastructure is also generating a load of log messages? So in that case, I might have a lot of log messages associated with some of the backend infrastructure, and there's various ways we can analyze these. And one way that we can analyze these, if the data is unstructured, is by using a different machine learning technology to pre-classify the data and then perform anomaly detection on that. If you've already classified the data, then you can perform a very similar analysis to the one I performed earlier using multiple metrics. But in this case, what we're looking to do is to take that set of log messages, categorize them into different groups using string similarity and different clustering heuristics. And then based on that, we can then run anomaly detection on those. So if there's significant increases in particular types of messages, or there are rare messages, they will come out as anomalies in the system. So this gives you some way of analyzing this unstructured log data and then correlating it to other things that are happening in the system. So going into how I do that, I can go into the third create job type that I showed you before. In this case, we're looking at messages. Okay. And there's a lot of documentation regarding this on our website. We've pulled across a lot of documentation. So in terms of some of the things I'm going to be going through here, in terms of the different options you've got here, that's available on our website. Going back to the page. In this case, the way the raw data is effectively there's a field called message, and that's the field that I want to look for anomalies in. That's the field that I want to categorize, cluster together, and then look for unusual increases in message rates and unusual rare messages. Okay. I can find the tab to go back to. So here I'm looking at count, and we create a special category when we do this categorization called ML category. These messages is across different hosts, so I want to look at the log messages on each host effectively independently. And when I get the results, I'll talk about influencers. Now, this is going to show you typically what you can do in terms of configuring a job. So I can look at historical data, and I can look at that up to a particular end time, or I can look at that up to no end time. And what it means is when I go to no end time, it's effectively behind the scenes, we're going to be continually running this process, continually analyzing the data, continually adapting the models as new data is being streamed in, and writing anomalies back to Elasticsearch. So running this, the same process occurs where we take the log data is being streamed into us. We're performing the categorization, and then we're analyzing the resulting data as time series. Then drilling into this, we've identified that on a particular host, there's some unusual log messages. And here we've got some sort of examples of these unusual log messages. And when you look at sort of the messages that are here, you can see that these are rare. These are different to the common log messages that were being streamed out there. Now, that's great. And I've shown you different types of analysis. But in an operational system, often one of the things that sort of is really powerful is when you start pulling this together. And sort of one way that I view the IT ops use cases, really I want to see how my system's behaving. Ideally, I want to analyze metrics from my application, metrics from my backend services, metrics from my infrastructure, log messages associated with those and all, and get some view about, like, is something changed? Has something changed? So ideally, I want to automatically analyze that and pull all the changes in system behavior together to give me some sort of holistic view into something's changed in my system, and here are the subset of things that are useful to potentially look at the root cause of the failure. So going back to the view here, I can take those jobs that I selected before and do exactly that, where I can effectively look at the anomalies across these different views, consolidate them together in that overall score. And down below here, I've got the description of this, which is the drop in KPI, the drop, the increase in response time of this service, and the error message. And really, sort of that's the goal of what we're trying to achieve in operations, is to filter through all that data that you have available, show you what's unusual, and boil that down into something which is actionable. And something that I haven't mentioned is what's on the left-hand side here, which are the influences. And there's a lot of work we've done in terms of counterfactual reasoning, in terms of trying to help pull out the most important attributes related to these anomalies, to try and give you sort of like an at-a-glance view in terms of what you should be looking at. And in this case, we're identifying a particular SQL Server and the backend inventory service as the things which we think are anomalous at the same time as that KPI. Okay, so I've run through an example there, but there's a lot more as well. And just to give you sort of a taste of some of the other capabilities we have, I want to sort of go into something which we call entity profiling. And in this case, really, this is something that we can do in the security space, but we can also do it in the operations space, where we're looking for unusual clients, unusual users, unusual processes. And we're looking for deviations between a particular client and the population. So we can do this at large scale. So if you've got hundreds of thousands or millions of IP addresses hitting your website, we can tell you, if there are unusual clients compared to typical clients interacting with your website. And this is quite useful to identify, and differentiate things like bots, or differentiate malicious use from typical usage of your website. And again, as Steve said, for sort of insider threats, this is sort of one way we can identify actors exfiltrating large amounts of data compared to typical usage. And really, sort of the goal here is that we're creating these profiles, and instead of just looking at one metric, we can look across multiple dimensions and create these sort of multi-dimensional probability distributions of how a client's behaving. And if a normal client's behaving like this and someone is behaving like this, we can then calculate the probability of that and raise that as an anomaly. And we can do this across different categories, different metrics, and so on, and pull all of that together into an anomaly to say this person is unusual because of this, this, and this. So how we do that in the product is, again, through the advanced job configuration. And in this case, I'm going to be looking at access logs again. And these are just very similar to standard Apache access logs. And in this case, I'm looking at if there's a high count of status values. And in this case, I'm going to be using the over field. And as explained in the documentation, this really defines the population, the field that describes the population for you to analyze. In this case, I'm looking for clients in the population which have high counts of any status field and aggregate that all together. Okay. So again, this is actually quite a few million records running on my laptop. So it's probably going to take 30 seconds. But effectively, just sort of reiterating what we're doing here is the machine learning component here is now a native part of the ML cluster. It's a plugin that you install with XPack, and effectively what we're doing is we're querying Elasticsearch, taking that data, pushing it through the ML plugin, which is performing the modeling, and then importantly, the results that we create are then written back to Elasticsearch. So as they're documented in Elasticsearch, you can then use them like any other documents. You can create watches on them, you can create alerts based on them, and so on. You can investigate them in Discover if need be, if required as well. Okay, so drilling into the results here, I'll see that there's a particular client that's unusual, and scrolling down to the results, I can say that this client was unusual because the number of times they received 404s and 302s was very different to the typical usage. So their profile was different across these dimensions, and this client is behaving unusually compared to a normal user. Okay, so I know that's been quick, but hopefully that's given you an overview of some of the features of the product. As I said, I recommend starting simply. It's always a temptation to try and use all the capabilities and try some really complicated use cases, but I recommend starting with some simple metrics and then building out from there. And hopefully we'll post a load of examples of how you can use this. Now, what I'm going to talk about a little bit is how this fits into Elasticsearch. And again, as Steve mentioned, this technology came from a company called Prelert, and at Prelert we were sat on the side of Elasticsearch, and we were pulling the data from Elasticsearch, we were analyzing it from Elasticsearch, and we were writing it back. So for us, it's been a pretty hectic time since September and the acquisition. But now we're really excited to be like a first-class citizen sitting in the Elastic Stack. And the advantages this gives us is that it's just a really simple install. We're deployed with XPack, and with all the other good features we've got in there, we're part of that. We're part of that ecosystem. And one really exciting thing is the data gravity. The data that we analyze is in the Elastic Stack, and we can analyze it and make really optimized calls to analyze that, and use aggregations and other features that are available in Elasticsearch to analyze that data. And then when we actually create anomalies, we write those back to Elasticsearch. So in Kibana, you can view the anomalies in the same context as your original data. Everything's there available, and we can create good visualizations, and you can also see the anomalies in that context. And then, as I'm going to talk about in a minute, we can make use of Elasticsearch's distributed architecture to also distribute our jobs, and also to be resilient to node failure. And that's really exciting as you start scaling up machine learning, as you start running more jobs across larger data sets, that we can actually distribute our jobs in a similar way to how Elasticsearch distributes some of its workload. So in terms of sort of what happens is when you install XPack machine learning, we recommend that you enable machine learning on initially maybe just a couple of nodes. And probably it's not, if you've got a production cluster, it's probably not a good idea to do this on your data nodes or your master nodes, but potentially create some separate nodes for you to do the machine learning jobs on. The machine learning load should be relatively small. It shouldn't, I mean, particularly for the smaller jobs, you should only require a small number of nodes compared to your Elasticsearch cluster. But just for production systems, particularly running near the sort of a high index level, we recommend that you create a couple of additional nodes which you run the machine learning jobs on. When you create a job, like I did in the demo, what happens is that the master enumerates the nodes you've dedicated to machine learning, and then the job is opened on one of those nodes. And as I mentioned earlier, the master automatically distributes the load across the ML nodes which have been dedicated to machine learning. There's then a data feed started, which is effectively the process of us retrieving the data from the Elasticsearch cluster, and then finally, when we've performed the analysis, we write the results to an index, so you can query it using Watcher, etc. When a node stops or fails for some particular reason, we will automatically move the job to a different node, and so we're resilient to that type of failure. And the job will continue from where it left off. And so these type of complexities, dealing with large real systems, are something that we've baked in from the start in the product as we've done this tightly coupled distribution. Okay, so hopefully, as you're aware, the initial beta is now out. We released that in 5.4 on May the 4th, and please try that. Please give us your feedback. It'd be really exciting to see how you're using it, what your experience is. And the GA release is planned for 5.5, which is late June. Okay, so with that, I'd like to hand it back to Steve Kearns, and happy to field any questions you have.
Awesome. Thank you, Steve. That was great. So I've been monitoring the IRC channel, and I can see we've got our engineering team and solutions architect team all over it, helping to answer questions as well. We've had a whole bunch of them. You've been talking for a while. Maybe I'll tackle one very quickly that came up a number of times. Is how do I create alerts on top of an anomaly that occurs, right? And you highlighted a couple of times that machine learning actually writes the anomalies that we detect back into Elasticsearch into a results index, and so really it's just a matter of creating a watch on top of essentially the machine learning anomalies results index, looking for a particular anomaly score that's above a value that's of importance to you. So I think that's a really good kind of question around how you create an alert when an anomaly occurs. So another question, Steve, I see you just joined us again. One of the questions that maybe is a good one for you is, how much training data do you actually need to build a model? So we saw in your example, you were looking over some historic data. It looked like at least a couple weeks worth of data, but what does it look like for a user as they're thinking about, like, how do I get this thing started?
Sure, that's a great question, and I think one of the key things is we use unsupervised machine learning. So we're effectively learning continuously as the data is being streamed into us. So we don't have this sort of formal training phase followed by a testing phase, and using the model, using the trained models to evaluate predictions. I mean, in reality, as you saw in the example. It took us sort of just over 2 days to infer that there was daily periodicity in the data, if there's weekly periodicity and there's very strong behavior at weekends, which differs significantly, then 2 weeks is a good measure, so we can actually start actually looking at actually understanding that weekly periodicity and modeling it very tightly. But having said that, the whole approach we use, the whole algorithms we use, and the Bayesian approach we use in the back end should give you, our goal is to give you, as accurate inferences as we can at any point. So as you saw, even after sort of a day or so, if there was a significant outlier, that's something that we would have alerted you on. And so, that's really the goal, is we're embracing the uncertainty in the data. We actually use we actually use in our calculations a calculation of how much data we've seen in terms of how uncertain we are in our predictions. So, a few days is good, a few weeks could be better.
That's great. Yeah, it's good guidance. I know there's no one simple answer to a question quite like that. Another one that came up a lot in the chat that I saw, and I'll sort of tackle this one, is how is this licensed? So this is a feature of XPack, and I posted in there. I'm sure somebody can post it again. A link to our subscriptions page that outlines exactly what features are available at what license level. Machine learning is available at the platinum level. And again, it's important to note that we have customers that are small two-person startups, and we have multinational companies and enterprises in our customer base. So it's not like we're just catering to one audience. So if you do have questions about how it's priced or how it works or what how it looks like for the cluster and the use case like you've got, don't hesitate to reach out on the subscriptions page. I think there's a contact me link right there that'll let you get that information very, very quickly from our team. Another question for you, Steve, is around sizing. There's sort of like a couple of questions that we're sort of rotating around. What does a typical spec look like of a machine learning node? Like how many jobs per node? And it varies a lot, I'm sure. But give us a sense of some of the parameters that we're working with here.
Sure. So I mean, typically, the work we do will be a bit more CPU and resource and memory intensive than some of the indexing type operations. But one thing you shouldn't confuse us with is a large sort of a huge neural net that requires a farm of GPUs. What we're doing is very much focused on using a small amount of resource. So for single metric jobs, as you saw, I was running that on my laptop in several seconds across like several million records, and there's two components. One is the query load. We need to make the query, but that's no different to you doing a search in Elasticsearch. And then there's actually the machine learning load. But for single metrics, we should only be using sort of small numbers of megabytes per metric we're analyzing. Having said that, once you start getting into the larger population models, then we will be using bigger models and more resource. So I think it's sort of that's where my advice to start small and start build it out comes in. I mean, generally in a proof of concept, we'd just allocate a normal size node to do the first analysis and then build it out from there.
That's great. Yeah, I think that's really good advice, is to start simple. This is one of the places where I personally got a little twisted up when I first got involved in the technology, was trying to say, wow, look at this technology, I could do all of these crazy things. But actually, I had the most success when I started with the most obvious KPI, and then built on top of that to a multi-metric, and continued to sort of march through the valuable, straightforward use cases, because it works just so well on those. It's like the low-hanging fruit, collect that first and grow from there. Another question that's sort of an interesting one, I think, is what is the performance impact of real-time jobs? So you mentioned like the model size is different depending on the type of job that we're running. But what about for a job that's set up to run live? What does that mean? Like, what does live mean even?
Sure. So what we're doing is the data is being indexed into Elasticsearch as normal, and we're querying Elasticsearch. So there's a small latency behind the data coming into Elasticsearch and us querying it. But we're querying a small amount. So we'll query, say, 5 minutes worth of data, after it's been indexed into Elasticsearch. So there's the cost of making that query, and then there's the cost of us analyzing that. But that's generally very small, because the cost of us analyzing, say 5 minutes data, particularly for some of the simple metrics jobs, is significantly takes significantly less time than real time. And as you saw, I analyzed 2 weeks of data in a few seconds. So the cost of analyzing in real time is generally less than some of the historical jobs you run.
Oh, that's great. Yeah, and that makes a lot of sense, right? Because you're only processing a smaller chunk. And this just for the record, for folks who are listening, is one of the big benefits of this being an online learning algorithm, is that we learn incrementally. So we're not going back and doing a full batch process of all historic data to add the new data and all of that. It's constantly learning as new data enters the system, and then it's processing the new data, detecting if it's anomalous, and then adding that back to the model and learning again. So it's a nice, very efficient process when it comes to that sort of thing. Another question that we've had a couple times is questions around sort of the roadmap for where we're going from here. I've seen a lot of questions around forecasting because it's a similar technology. I mean, we're sort of forecasting one bucket into the future and comparing reality to our prediction. So what does it look like? What are some of the next steps for the roadmap here? I know that there's still a lot to be done, but I'm just curious.
Sure. So I think the first thing we want, one thing that we're constantly trying to do, and one of the first things we want to do is to make this easier to use across different job types. Like some of the job types here, I went into the advanced configuration, and we want to shrink wrap more of those to enable you to have the power of all the modeling, this complex modeling we're doing, but without having to understand the complex models we're creating. So we're planning to effectively shrink wrap configurations on top of beats, on top of file beats, on top of metric beats, on top of some of the log stash configurations, and shrink wrap dashboards and how you can alert off that. So that's just a really seamless, simple way of using the entire Elastic Stack from beats right through to alerting. So that's one thing that we're focused on in terms of helping you get the operational benefit of this. In terms of more technical features, forecasting is one that we're currently working on. Our models are actually capable of providing good forecasts, and so that's something we're now looking to put into the product and looking at the best way to do that. And by forecasting, we're effectively meaning extrapolating into time, like what is the likelihood of my memory being 32 gigs in the next week, for instance, those type of use cases. Now, outside of that, longer term, as you said, Steve, I think we're really excited about being the machine learning group. We know that, say 40%, 50% of Elasticsearch customers put log data and metric data into Elasticsearch. But what we'd love to do is to enable more users of Elasticsearch to use these type of technologies. And so that's really where sort of additional machine learning capabilities that don't necessarily rely on time series analysis, but more potentially rely on more supervised approaches on non-time series data come in. And that's the type of things that hopefully we're going to be building between now and ElasticOn, or maybe sooner. So watch this space, I think.
Oh, that's great. Yeah, and one of the key things that stood out to me there is direct integration for some of the straightforward use cases where we know the data. And this, for those that aren't familiar, I sort of alluded to this in the introduction, but we recently in FileBeat, we introduced this notion of FileBeat modules that have a built-in knowledge of where a common data type like Apache logs or Nginx or MySQL and so forth, where these log files live, what the enrichment typically looks like, and package things like dashboards with them. And so, as Steve was alluding to, we want to add machine learning jobs to those configurations as well. So for these common data sources, this just becomes part of the package that people see. So very, very powerful there. Another one that came up that I think I can address pretty quickly is, will there be any tutorials available? And we have good news. We actually have a series of videos. So the process that Steve went through of showing us these different types of anomaly detection jobs that he had created, we actually have short videos that walk you through a lot more slowly, sort of talking to you a little bit about data and inch you through that on the website. I'll paste one of those into IRC, but we can also include that in some of the follow-up emails and things like that. So there's a lot of great material that we've produced here, and this will also be available as a recording, so you can rewatch this and sort of play Steve in slow motion to recreate some of the jobs that he's made here. So in terms of other questions, there was a question around how do you keep large anomalies from skewing the model for future data? Gets a little bit technical here, but maybe it's useful just to touch on some of the techniques that we use, and maybe even touch on some of the sort of algorithms more broadly, just to give people a sense of what family of algorithms this this is using. Is it deep learning? Is it neural nets, which are basically the same thing, or is it something different entirely?
Sure. So I think like for a start, I think my colleague Tom Vesey, who sort of does really the majority of the R&D on the approaches, is presented at Elasticon, and there's a talk available on our website, which is actually sort of a good starting place if you want to get a bit more of a deep dive into some of the algorithms we use. We've also got sort of academic papers, etc., that are available to give you a bit more detail. But just so addressing the first question in terms of large anomalies skewing your data, yeah, that's absolutely something that you need to be aware of. But we actually allow for that. We use a technique called windorization to allow for to actually allow for that. So in fact, the less probable something is, the less it will affect our models, is sort of one way of looking at that. And again, there's some discussion of that at the Elasticon talk. In terms of the general approach, set of approaches we use. I mean, effectively, what the models that we create are effectively basically, we end up with sort of these complex multimodal probability distributions sat on top of trends. So we model the residuals with these complex probability distributions, and we have these trends that describe the periodicity and the long-term behavior of the data. Now, and really, the sort of the key part of the approach is underlying this is this Bayesian approach where we're automatically learning the parameters that describe those models. So in summary, that's sort of like a really high-level view, but I recommend watching Tom's video to get a bit more better understanding of what we do.
That's great. Yeah, no, it makes a lot of sense, and I think some of the keys there that really stand out to me. Once you've defined the job, you don't have to come back and tune anything or tweak anything. It's all learning from the actual data that it sees. And the neat part is, and you touched on this a little bit, is once we find an anomaly, we can actually do, I think of it as a series of statistical tests. It's quite a bit more complicated than that, but we can identify some of the influencing factors, whether it's a machine or a user or an IP address and so forth. And being able to give you that pointer to say, oh, this machine was likely to be related to this particular problem, gives you that extra pointer. And I think that's one of the advantages of the algorithmic approach that we've taken, is it's not a black box. It just says yes or no. We give you a little bit more visibility into sort of what and why and so forth. So really, really powerful stuff there. One that I think I can tackle relatively easily is can you create an alert when an anomaly occurs? We touched on this, I think, a couple of times, but I've seen more questions in the chat, and the short answer is yes. So the results that come back from machine learning, so when we find an anomaly, we write that back into Elasticsearch in a dedicated results index, and from there we can go and use Watcher to actually say, notify me when, via email, and you can use all of the notification actions and so forth that Watcher provides, whether that's Slack or HipChat, PagerDuty, email, and even a webhook to integrate directly into your own systems. Maybe let's try to take one more question. So one more. One of the questions that I touched on at the beginning is, when will this be available on cloud? And so this is one, maybe Steve, I'll tackle this one briefly. So we're working very closely with the cloud team. As Steve described the architecture, in most production scenarios, we're strongly recommending having a dedicated machine learning node for the same reasons we recommend having a dedicated master node. And what that means is that you need to have a dedicated node type. And in Elastic Cloud today, we don't allow you to configure dedicated nodes of different types. And so we didn't want to release this and potentially give people an experience that was either really, really complicated to configure, so you didn't have data on the same nodes that you had machine learning. And so we're going to be gating it on that feature. So I know that the Elastic Cloud team is hard at work on providing this sort of dedicated node type support in cloud and in Elastic Cloud Enterprise. And so stay tuned. This is something that we're hard at work on. We'll have an update for you, I'm sure, in the not so distant future. Okay. I think we're starting to run low on questions here. I think that there's a lot of good questions going on in the IRC channel as well. Steve and I will jump in there, join the team. One thing just to mention, as you guys are downloading this, please go download XPack and install it. It is very easy to do. It's one command to install into Kibana, one command to install into Elasticsearch, and at that point you get a 30-day trial license to go wild. You can create as many jobs as you like and so forth. And if you do need a trial license extension, or maybe you've already got a basic license and you're using XPack for monitoring, don't hesitate to reach out to our team. Send a note to info@elastic.co, and we can send you an additional 30-day trial license very, very easily to work with the technology. Again, any questions you have, please hit us up. From time to time we'll be on IRC when we do these webinars, but for the rest of the time, do please join us on the Discuss forums. Right under Discuss, category of Elasticsearch, and category of XPack, ask away there. The machine learning team, myself, Steve, and others are waiting to jump on some of those questions you might have. Again, thank you all for joining us, and Steve, thank you so much for sharing your knowledge.
Thanks.
Right. Cheers.